So the second part of this session is going to be looking at the dermis. So as we already know, the dermis helps to anchor the epidermal accessory structures, but it consists of two different layers. We've got the outer papillary layer, which you can see is next to the epidermis, and then we've got the deeper reticular layer. The papillary layer, this consists of our areolar tissue with smaller capillaries and lymphatics and sensory neurons. It has dermal papillae projecting between the epidermal ridges. So this is what you can see there. You can see these projecting papillae. And the reticular layer consists of dense, irregular, as you can see in this image, connective tissue. It has some larger blood vessels as they get smaller as they move into that papillary layer. So we're starting to form the capillaries there. It contains the lymph vessels and it contains the nerve fibers. And the whole layer contains collagen, elastic fibers, and connective tissue proper. Now, you'll also have heard of dermatitis, which is inflammation of the dermal layer, of course. And this primarily occurs, so dermatitis is acute inflammation, but primarily of that papillary layer. And that's caused by infections, radiation, can be mechanical irritation or chemicals. So, for example, a variety of poisons, such as poison ivy is a great little example. And it's characterized by itching plus or minus pain. Now, the dermis is strong, and that's because of those collagen fibers that we're talking about. It's elastic because of the elastic fibers that we're talking about, and therefore it has flexibility, which when you're talking about proper terminology, you're thinking about skin turgor. But of course, people, in particular, as you get older, you get sagging of the skin, you get wrinkles, and that's because of reduced elasticity. Why do we get that reduced elasticity? Well, you get it because as we age, we produce less of the elastic fibers. In dehydration, it'll occur. There are a variety of hormones that can affect it, but also UV exposure and UV damage. And then you might get stretch marks, and these can be due to thickened tissue, and that thickened tissue can result from excessive stretching of skin. That can be down to pregnancy or weight gain, for example. It's also interesting that we have what are called lines of cleavage. And so, put crudely, the collagen and elastic fibers in the dermis, they're arranged in parallel bundles. And that's what you can see in this image. And so therefore, they're helping to resist force in a specific direction. And they do help to establish important patterns because a parallel cut will therefore remain shut and it'll heal quite well. Whereas a cut across or at right angle to this line of cleavage pulls open and is more likely to scar. And then we've got tattoos, and obviously being a Welsh boy, I put a nice little Welsh dragon in there. But where does this actually stain? Well, it's the dermis. It's the dermal layer that is the receptive site for the pigment of tattoos, just so that you know where they go in case you've got one and you're interested. I don't, by the way, that's not my arm or leg or whatever it is. So, dermal circulation. So we do have that dermal circulation. We have the blood supply going in there, and we have the cutaneous plexus. So that's a network of arteries along the reticular layer. The papillary plexus is obviously the capillary networks, and that comes from small arteries, all the small arterioles. So we've got the arteries and the arterioles going into the capillaries in that papillary layer. And then we've got the venous plexus, is the capillary return deep into the papillary plexus, as is obvious. And the presence of blood vessels in the dermis means it plays an important role in temperature regulation. So that's where we're getting that vasodilation, that vasoconstriction to help lose heat or lose less heat, as the case may be. You have contusions, that's damage to blood vessels resulting in black and blue bruising, of course. So you know the phrases again. And again, we've got the nerve fibers in the skin, help to control blood flow, gland secretions, and of course, we've got those sensory receptors. So you've got motor neurons in there, and you've got the sensory receptors as well. So the key points to this: the dermis helps to provide mechanical strength, flexibility, and protection. It's highly vascularized, it's got a decent blood supply, and it has lots of different sensory receptors within it that we talked about much earlier on. So a couple of questions for you to think about. So have a read of these, press pause before I go through the questions and answers. Which structures contain connective tissue, blood vessels, and nerves? The answer, of course, is B, the papillary and reticular dermis. Next question. The phenomenon known as goosebumps is often associated with shivering to reduce heat loss. What integumentary layer is most directly related to this reflex? So this will be a bit harder for you to think about. The answer is B, reticular dermis. So hopefully you got that one right as well. In the third part of this in this session on the integumentary system, we're going to look at the hypodermis and the integument accessory structures. So the hypodermis, obviously, or the skin rather, is anchored to the underlying tissue, which may be the muscle or bone, by the hypodermis. So remember, epidermis, dermis, and then we've got that subcutaneous tissue, or the hypodermis as it's also known. It's made up of elastic areolar and adipose tissue, and is connected to the reticular layer of the dermis by connective tissue fibers. It has very few capillaries and no vital organs, and the deposits of subcutaneous fat have distribution pattern determined by hormones. So cortisol, which is your long-term stress hormone, helps to determine where subcutaneous fat distribution goes, likewise estrogen. So most fat cells are housed within the hypodermis, and throughout the body, they're known obviously as adipose tissue that you'll already know. Subcutaneous fat can be reduced through cosmetic liposuction, and obviously it's the site of subcutaneous injections using hypodermic needles. So now we're going to look at a couple of those integumentary accessory structures. So we're going to be thinking about hair and nails. We're only going to be covering them at a very basic level. You don't need to know this in particular depth. So we've got, first of all, we're going to think about the hair. And so we've got, if we're just looking at this diagram, you can see a crude structure of the hair. You've got the hair papillae there, a bulb, you've got connective tissue sheath around it. You've got your hair root. That's your erector pili muscle that helps to make the hair stand on end. You've got your sebaceous gland, which releases sebum, which is that oily-like substance that is secreted, keeping the hair nice structure, if you like, but also providing essential oils onto the skin. And you've got your hair shaft. So the hair and the hair follicles, the sebaceous glands and the sweat glands and nails, they're all located in the nerve in the dermis, which is the layer we're showing here, and project through the skin surface. The human body itself is covered with hair, except on the palms, soles, lips, and portions of the external genitalia. And it helps to protect and insulate, guards openings against particles and insects, and is very sensitive to very light touch, as we've already talked about, and as you will already know as well. Because touch, what is the purpose of it? Well, the hairs, in essence, are trying to help increase the sensitivity of the skin to touch. And in some species, this is very, very finely tuned. For example, the whiskers in a cat are exquisitively sensitive. It's got an even more important role in some species is heat conservation. So hairs play a very vital role there, but in humans it's not very significant because even the hairiest human is pretty relatively hairless compared to those other species that are very hairy. The hair follicle itself is located deep in the dermis and produces these non-living hairs. It's wrapped in the in a dense connective tissue sheath, which we've already talked about, which is showing there, with the base surrounded by sensory nerves, which is your root hair plexus that we've talked about, which when your hairs move, it stimulates that root hair plexus and you get that sensation that something has touched your skin. And each hair follicle is lined by special keratin-producing cells which secrete keratin and other proteins that help to form the hair shaft as it grows outwards. So the hair root is the lower part of the hair, which is attached to the integument, and the hair shaft is the upper part of the hair and is not attached to the integument. As hair is produced, it's keratinized, as we've talked about, and that leads to that hair shaft formation. And hair accessory structures include the erector pili muscle that we've already talked about, which causes the hairs to stand up and end. And the erector pili muscles have an important role in some species because they help to trap air next to the skin, therefore warming the air and preventing heat loss. We do have different types of hair. We don't need to worry about it too much. You've got the velous hairs, which are soft and fine and cover the body surface. You've got terminal hairs, which are heavy and pigmented. They're present on the head and the eyebrows and other parts of the body after puberty, for example. What about hair color? Well, that's produced by melanocytes at the hair papillae, and it's determined by your genes. So nails. You really don't need to know very much about nails at all, to be honest. So the nails are made of dead cells, which are packed with keratin, and they help to protect the fingers and the toes. Like I said, you really need to know very little about it. They correspond to the hooves and claws in other species, but it is important to know that the structure of the nails can change in some diseases. So some metabolic disorders, for example, could change the nail structures. So clubbing of the fingernails that you might see in liver disease is an example. So these are things that you'll cover at a later point. So just remember that these structural changes can have can be an important sign of disease processes going on. So now we're going to talk about the exocrine structures. So of course, the exocrine structures, we're thinking about the release of sweat and we're thinking about the release of sebum. So the exocrine glands include the sebaceous glands, which secrete the oils, that's your sebum, and the sweat glands, which release sweat, which is a nice watery secretion. And if we have a little look at this, you can see the sebaceous glands, you've got them present here, and you've also got them present along with the hairs themselves. And there's your rectipilli, just so you remember what it is, and your root plexus, which is your nerves, which are looking at the sensation or detecting sensation of movement of the hair. So the sebaceous glands lubricate the hair and help to control bacteria. And the sebaceous follicles discharge, which you can see here, here's your sebaceous follicles, they discharge directly onto the skin surface. So the sebum contains, what's that present in the sebum, which is being released by these sebaceous glands? It contains lipids, and it contains other ingredients, like I said, which lubricate and protect the epidermis, which is our skin layer, and they help to inhibit bacterial growth. It also helps to make the skin more waterproof and prevent them from drying out and cracking. So, for example, chapped hands or lips indicate insufficient protection by sebum. And the sebaceous glands, they're particularly active during adolescence, which helps to cause the oily skin, which is common among teenagers. That's all we're going to cover on that, really. We're going to now talk a little bit about sweat glands. And as you know, they release a dilute salt solution through sweat pores onto the skin surface. The evaporation of sweat helps to cool the skin and is important in regulating temperature. Now, on average, sweat glands produce around about 0.5 litres per day to over 12 litres. So when you're maximally exercising and you're adapted to the temperature, you can produce up to or more than a litre per hour of sweat. And it's produced in response to activation by the sympathetic nervous system, as well as overheating. So just thinking about when you're really nervous about whatever it is, you suddenly start sweating. So sympathetic activation of sweat glands. But if we're looking at the structure, there are actually two main types of sweat glands. Now, these are called the apocrine and merocrine. Merocrine is also called the eccrine glands. Now, the apocrine glands are found in your armpits, around the nipples and the groin, and they're associated with hair follicles, and they produce a sticky, cloudy secretion. So this obviously is a little bit of histology of the apocrine gland, and you can see the myoepithelial cells around it, which constrict to squeeze fluid out, so to speak. And you can also see, looking at the structure, you've got your sweat pores there, you've got your apocrine duct coming onto the hair follicle as well. Now, the apocrine sweat is odorless, it's protein rich, and it supports growth of surface bacteria. And we'll talk about it in a little bit, remembering where it is. It's in your armpits and groinal areas. So interestingly, it was initially thought that the apocrine and merocrine or eccrine secretions were different. Now appears that they both release the same actual sweat secretion, but the apocrine secretion mixes with sebum from the sebaceous glands and is released at the skin surface, while that doesn't happen with the eccrine secretions, and that's what we'll talk about next. So if we got those secretions of sebum and sweat together being released, the bacteria then decompose these secretions, and that's what produces the volatile, the really smelly odor molecules that give rise to the characteristic odor that individuals produce. And the presence of that auxiliary hair also makes the odor even more pungent, because the secretions, the debris, the keratin, so the protein and the bacteria, they all accumulate on the head and they all get broken down. It all starts to smell. So unlike the eccrine or the merocrine sweat glands, which secrete continuously, the apocrine glands secrete in periodic spurts. So now we'll talk a little bit about the eccrine glands. So these are widely distributed on the body surface, especially on the palms and the soles. They discharge directly onto the skin surface, and that is your sensible perspiration. And remember, it contains things like your water, your salt, and your organic molecules. The eccrine sweat therefore functions to help cool the skin. It excretes water and electrolytes, and it helps to flush microorganisms and harmful chemicals away from the skin. So what you can now see is that the eccrine sweat helps to remove bacteria from the skin, whilst the apocrine sweat appears to stimulate bacterial growth, and you get that smelliness associated with it. Other integumentary glands, well, the mammary glands produce milk, and then you've got glands that put it in within the eardrum, within the ear itself, and the eardrum. They produce earwax, so they help to protect the eardrum. Those glands release earwax, which then protects. Just as a slightly side something interesting for you to know, where does all the earwax that you produce actually go? Because it drops out basically when you're talking, because you're moving the jaw, which is helping to move it around, and by movement of the head, and it basically just drops out over time. Where does it actually drop out? Well, a large proportion of it drops out on your pillow. So if you're sharing a pillow with someone, or sharing a bed and a pillow, whatever, you know you're going to be sharing quite a bit of earwax with them as well. Lovely. So another little question for you. Press pause, as usual. Have a think about the question, and then we'll go through it. Okay. Hyperhidrosis is characterized by excessive sweating, especially at the palms of the hands and soles of the feet. Which of the following could cause this disorder? Only one of them's right, just so you know. The answer is D, increased stimulation of the eccrine or the merocrine glands. Right, so now we're going to move on to burns and the skin. And we're not really going to cover this in any detail because this is stuff that can be covered at a later point. And we're thinking about disorders. So burns are a threat to life because they can lead to catastrophic body fluid loss because you lose lots of fluid through burns, obviously. And that can lead to dehydration and fatal circulatory shock, as well as to a variety of infections coming in. And of course, infections and skin cancers are of course, other types of skin disorders. But if we're thinking about burns, you've got your burn types. You've got your first degree burns, which is such as your sunburn, which is really affecting your epidermal layer. You've got your second degree burns, which are affecting your epidermal layers and the upper part of the dermis, and that can lead to your blisters, for example. You've then got your third degree, which is your full thickness. So if we're having a little look at some of the examples, just a nice little, or not nice, as the case may be. You've got your first degree burns. There you can see a little bit of sunburn. It's really only affecting the epidermis and leads to redness. Second degree burns, epidermis and dermis with some blistering. Third degree, full thickness, destroying the epidermis, dermis, and often projecting down into the hypodermal layer as well. And you can estimate burn damage, and there are a variety of ways to do this, but a simple way that has been developed is looking at the surface area being divided into multiples of 9, or the rule of 9s. And so you can see with this, the head contributes 9%, each upper limb 9%, lower limb 18%, so 2 lots of 9. You've got your trunk, which is 36%, so 4 lots of 9. And so you can see how it's broken down into those rules of 9. So if you've got over 10% of the body has third degree burns, it's a critical burn. Likewise, 25% of the body has second degree burns, or third degree burns on the face, hands, or feet. So the last little bit we're going to go through is looking at skin repair. And this is a very, very easy version taken from a textbook, and you'll need other versions to get a little bit more depth into it. So if you damage your skin, you get localized skin repair. It starts with bleeding and activated mast cells, and you start to get initiation of the inflammatory response. You start to get germinative cells migrate around the wound. Macrophages clean up the area, and fibroblasts and endothelial cells and other cells move in, and they start to produce this granulation tissue. So here you can see the damage to it. So you've got damage to the epidermal and the dermal layers there. You then form a scab. So you can see the macrophages and the fibroblasts that are there and the migratory epithelial cells. And this is the granulation tissue that I've just talked about. And so a scab forms and that starts to stabilize and protect the area. You then start to produce your scar tissues. This is your step 3. So the fibroblasts produce your scar tissue, inflammation begins to decrease, and the clot itself is disintegrating. And the scab has been undermined by epidermal cells that have migrated down, as we've already talked about, and the phagocytic activity is pretty much ended at this point. And then finally you get the fibroblasts, which start to strengthen that scar tissue, and you start to get initially a raised keloid structure. Raised keloid starts to form. So the final bit I want you to think about. So like I said, you need to know a little bit more on healing than that, but that's just to give you an overview of the process involved. So aging. Aging has lots of effects on the integumentary system. So I want you to just have a little look at this. This is the effect of aging. So we get epidermal thinning, decreased number of Langerhans cells, decreased vitamin D production, decreased melanocyte activity on the whole. There's a nice little list there for you. And I want you to press pause and just think, what is the consequence of each of those effects on the individual? What is going to be happening? So press pause and have a really good think about these before we go through them. Okay, the first one, epidermal thinning. So what's the effect of that? Well, if your epidermis is thinning, you're starting to, because of a stem cell production, that starts to decline with age. That causes that epidermal cell production to slow, and therefore your cells start to become larger and more irregular. And this causes a thinner, more translucent skin. So therefore, as we know, you'll be more susceptible to skin injuries, tearing, and bruising. What about the next one? Decreased Langerhans cells. Well, of course, this is your macrophages. And if you do that, and with age, you lose about 50% at old age, 50% of the number of macrophages. So therefore, you've got an increased rate of infection or increased risk of infection. What about decreasing your vitamin D production? Well, of course, that means if you've got decreased vitamin D, you have reduced calcium and phosphate absorption in the GI tract, as well as other things that vitamin D does, which means you get decreased bone mineralization and potentially thinner bones, so osteum. So basically, you're not getting as much mineralization of your bone, which is osteomalacia. Decreased melanocyte activity. Well, remember, of course, melanin, if you've got decreased melanocyte activity, you've got decreased amount of melanin being produced, and melanin is protective and it helps to absorb harmful UV rays. So this leads to an increase in your risk of sunburn and an increase in your risk of skin cancer. Interestingly, in some areas, melanocyte activity actually increases, and that can lead to dark spots on the skin. What about your hair follicles? Well, again, decreased melanin production leads to your white or your grey hairs, but also the hair can begin to thin in many people. We've got decreased glandular activity. So, for example, if we're breaking it down into sebum, first of all, if you're not producing that oily substance, your skin becomes drier, scaly, and more itchy. And if we're thinking about the sweat, of course, your ability to cool through sweating is decreased, meaning individuals can overheat on overexertion or on overexposure to hot conditions. Reduced blood supply. Well, of course, that's very similar. Again, there's the thermoregulation issues that you're able to vasodilate. You're not able to vasodilate as efficiently and therefore lose heat and regulate your temperature as well. But also you get decreased blood going to the nail beds, which can lead to dull, brittle, hard, and thick nails with a slower growth rate. It's also important to think that the rate of absorption of drugs applied to the skin will also be decreased if you've got decreased blood supply going there. What about the reduction in elastic fibers? Well, the skin becomes less elastic, causing sagging and wrinkles. And finally, slower repair. Well, if you've got slower repair, you've got longer healing times. For example, a standard blister will heal in about 4 weeks in a 25-year-old, but will take 6 to 8 weeks in a 75-year-old. And slower healing, of course, will lead to an increased risk of secondary infections.